Hello everyone, my name is Jason Pedreza. I'm a Senior Redshift Specialist Solutions Architect at AWS. And in the next 15 minutes, you will learn how you can achieve the best price performance in running your data workloads with Amazon Redshift. Every day, customers are challenged with how to manage their growing data volumes and operational cost to unlock the value of data for timely insights and innovation, while maintaining consistent performance. Data creation, consumption, and storage are predicted to grow to 175 zettabytes by 2025, forecasted by the 2022 IDC Global Datasphere report. And so as data workloads grow, cost to scale and manage data usage typically increase as well. So it's critical to look at what is the price performance in running data workloads in a data warehouse. So what is price performance? When looking at price performance, the question that needs to be answered is how much does it cost to get a certain level of performance in running a workload? Or to put it in another way, what is the performance that you get in running a workload for a given price? These two dimensions of price and performance is the basis when evaluating, for example, the SLAs of data ingestion or ETL pipeline, such as having stringent requirement to complete data processing before start of business or being able to refresh datasets every hour. When evaluating SLAs of BI reports and dashboards, this could mean the frequency in which data needs to be refreshed as per business requirements and the duration the required information can be readily accessed by end users. All of these things factor into the price performance decision. Only looking at the performance is half the story, and the same applies in only looking at the price. You could run a workload that performs well, but at a very high cost. That's why it's important that we look at price performance metric in order to normalize the performance based on how the data warehouse scales. As an example, let's have a look at this chart which shows two data warehouses, A and B, which runs the same workload. Data warehouse A has a smaller configuration, and as you can see, data warehouse B runs in 900 seconds, but this does not provide us much information in terms of price performance. What this chart tells us is that data warehouse B runs faster compared to data warehouse A. Now let's add another one into the mix with data warehouse C, which is a much larger configuration than data warehouse A. And as you can already see, data warehouse C has a runtime of 500 seconds and performs better. But still, we are not able to determine which data warehouse has the better price performance. The only way we can look at the price performance is when we include the price component in order to normalize the price performance evaluation. Now that we have the price information for all the three data warehouses we looked at earlier, which is A, B, and C, we can now see that both data warehouses A and C have the same price performance and that data warehouse B is much more expensive. And this iterates on the point that regardless of the absolute performance, we need to include the price when evaluating the data warehouse requirements for your specific workloads. This chart shows Amazon Redshift continuing to have better price performance than other cloud data warehouses. Amazon Redshift achieves this by focusing on improving the performance for real-world customer workloads by constantly diving deep to identify opportunities to deliver improved performance. One of the things that we also do is periodically evaluate Amazon Redshift using industry-recognized benchmarks against some of the other options that our customers have to ensure that we are delivering the best price performance. One of the benchmarks that we use for this evaluation is called Cloud Data Warehouse Benchmark. It consists of the data and queries derived from the standardized TPC-DS and TPC-H benchmarks. At the top chart is the result of running the TPC-DS component of the Cloud Data Warehouse Benchmark. The y-axis is the price performance, and the x-axis shows several popular cloud data warehouses. In this case, lower is better. And what it means is you spend fewer dollars in Amazon Redshift to get equivalent amount of performance. On the bottom chart is the TPCH component, and again, Amazon Redshift shows the lowest price performance. When you look at the 1.3x, 1.5x, it means that Redshift is able to run the same workload at the same time at 1.5x lower cost. And going back to the top chart on the TPCDS component, Amazon Redshift is able to run the workload up to 5x lower cost with the same performance. And so we evaluate the price performance using these two benchmarks when we are looking at comparative study, but are primarily driven by real-world improvements of our customer workloads. This brings us to another factor that we should consider when looking at price performance, which is price performance at scale. Just because a data warehouse can deliver the best price performance with the current data workloads may not necessarily mean that it will scale as well as the size of the data increases or as other workloads are added. It's important to also consider and plan that the price that you pay per terabyte or per workload in your data warehouse is going to scale well as your use cases do. To illustrate that, Amazon Redshift is able to scale really well. We have done a test that is represented in this chart, where in the y-axis, we are showing the price performance per terabyte, and in the x-axis are 4 different cluster configurations. This was ran against the same TPCDS-based test on a 30 terabyte, 100 terabyte, a 300 terabyte, and all the way up to 1 petabyte dataset. What this shows is that Amazon Redshift scales very predictably and linearly. It's a near constant price performance for this vast range of magnitude. And that Amazon Redshift not only brings the best price performance with the workloads that our customers have today, but we are also planning and making sure that it will scale well as our customer use case grows. Now let's talk about how Amazon Redshift continues to deliver on enhancements to improve the price performance. One of the improvements that has been made over the years is making sure that Amazon Redshift could scale with concurrency as well. And this pertains to the question of, will the price performance be maintained as the number of users accessing your data warehouse increases? We invested heavily in the ability of Amazon Redshift to auto-scale by introducing concurrency scaling. And this chart shows a sample test we ran to demonstrate Amazon Redshift's scalability. You can see in the x-axis the number of concurrent users issuing simultaneous queries to a sample Redshift cluster. And the y-axis shows the query throughput, which is the number of queries per hour. This illustrates that Amazon Redshift scales linearly when it comes to concurrency. The performance that customers get when they are the only user accessing Redshift can be maintained via concurrency scaling, whether it's a single user accessing the data warehouse or hundreds of users accessing the data warehouse at the same time. How we are able to achieve the best price performance is with our approach on performance optimization. We call this approach customer-obsessed approach to performance. The main idea is that performance optimization is never ending and that there are always areas of the code or hardware or software that can be improved and further optimized. And so the question becomes, how do we prioritize on what are the most important things to improve that delivers the best value to our customers? And here we use a three-pronged approach to tackle this. The first and probably the most important is that we are really obsessed with our customer feedback. Thousands of our customers are bringing in new and innovative workloads to Amazon Redshift all the time. Things that we didn't maybe anticipate, and they are building and innovating constantly. And we are very responsive and take all the feedback that we have from our customers and turn them directly into product improvements. This primarily drives the vast majority of the improvements. The second approach that we take is via fleet metrics, and since Amazon Redshift is in the cloud, we are able to collect hardware and software performance metrics which we continually monitor and dive deep on things which might lead to potential bottlenecks or performance improvements. And this is another rich source of optimizations that we work on to improve our price performance. The third approach is really about anticipating the needs of our customers. Our customers don't always know what they are going to need tomorrow, in a week, in a month, or a year. And so part of where we focus is thinking about where our customer workloads are headed, where the industry is headed, where we can find source of innovation, which may not be what our customers need today, but maybe what our customers need in the future. So an outcome of this is what is shown in this chart. The internal benchmark that we have going back from 2018 to today has the price performance of running the TPCDS benchmark going down from $11.77 to $6.71. What this means is that if you would have set up a Redshift cluster in 2018, load the data, run the benchmark, and shut it down, you will get a bill of $11.77. With that same test with Amazon Redshift Serverless, which is our latest offering, the same test today will cost $6.71. In terms of delivering value to our customers, price performance is a key pillar for us and is at the top of our initiatives. Some of the initiatives that we are investing in is called Autonomics, which essentially involves looking at our fleet and automating and optimizing various aspects of performance. One example of this is automatic table optimization, or ATO, which helps you automatically optimize your table layout in Amazon Redshift in order for your queries to run faster. All these are done seamlessly through machine learning algorithms. Another example is automatic workload management, or AutoWLM, which manages the workload running in Amazon Redshift automatically. We also have AutoMV, which allows for automated materialized view creations in Amazon Redshift, in which based on your workload, it seamlessly decides if you can benefit from having a materialized view. These are some of the examples, but there are many other autonomic features that we have. Our massive parallel processing architecture has been a foundational building block and has newer innovations in this area, such as AWS Nitro, which is a lightweight hypervisor that manages memory and CPU allocation and delivers performance that is indistinguishable from bare metal. A recent feature that we released last April is additional performance enhancements that speed up string-based query processing by up to 63x better performance as a result of our MPP architecture and AWS Nitro system. Other things that are equally important are our pricing flexibility, dynamic scaling, and our storage that allows to scale to petabytes of data while maintaining low latency and high throughput. The key takeaway in this session are every workload has to be evaluated on along two dimensions, which is price and performance. Next is that Amazon Redshift offers leading price performance for diverse analytic workloads that delivers up to 5x better price performance than other cloud data warehouses, and dynamically scale to improve query speed for complex and critical workloads. Lastly, you can visit the Amazon Redshift price performance page to learn more on this topic. Thank you very much and have a nice day.